Good morning, class. Our lecture for today is design of doubly reinforced beam, T beam. Yan yung sinend ko sa group chat before. Meron tayong dalawang sample, 1 and sample 2. Start with the data. So we have thickness. Ang kailangan dito ay thickness. Yan yung thickness ng flange. And then capital B. That is the width of the flange sa ibabaw. Tapos yung H. That is the overall height. And then small b. That is the width of the web. And then F prime C, Fy, dB prime. This is the diameter of the compression bars, or yan yung mga top bars. Then we have dB, or that is the diameter of bar, or that is the tension bars. And then we have mu. Take note that this is design, kaya given ang mu. Tapos meron tayong stirrup diameter, which is 12, and then the clear cover. The solution is a 3-step process. Ang una, determine mo yung balance condition and then maximum condition and then the design proper itself. So we start by determining the D prime, or that is the distance from the extreme fiber to the centroid of your compression bars. So that is D prime is equal to clear cover plus stirrup diameter plus dB prime all over 2. And your effective depth is equal to H minus clear cover minus stirrup diameter minus dB all over 2. So that's 530. And your beta factor. Okay. And then for balance condition, kailangan i-determine natin yung depth ng neutral axis, which is defined by C. So, small c is equal to 600d divided by Fy plus 600. And then, that is 361.36. You multiply that by beta to get your A, small a. Small a is the dimension of your balanced area of concrete. Or that is 307.16. You store that to memory A. Notice na si A, 307.16 is greater than your thickness T. Yan yung A. Okay? So meaning, your area of concrete is greater than A1 or the area of flange. Next is, kunin na natin yung actual area ng balance AC. So, makakatulong dito yung small a, which is equal to area 1 plus area 2. Yung area 1, that is the area of flange, which is capital B times T, plus area 2, B times the quantity A minus T. Now, you store that to letter B of your calculator. Okay? Next. So, again, A1 is equal to capital BT. A2 is simply balance AC minus A1. You store that to capital M of your calculator. And then we have the lever arms, Y1, 475. You don't need to store this to your calculator. Whole number naman yan. And then Y2, this is now the centroid of area 2 from the extreme compression fiber. You store that to Y. Now we compute your nominal balance moment. 0.85 F prime C times the quantity A1Y1 plus A2Y2 divided by 1 million. You multiply that by phi, you get capacity mu balance condition. Next is maximum condition. For maximum condition, remember na rho max is equal to 0.75 of rho balance. Ganon din sa maximum area of concrete, that is 0.75 of balance area concrete. So you store this to letter C, per calcul. And then we compare your balance maximum AC with your area of flange para malaman natin kung mas malaki siya sa area of flange, no? So, 168,967 is obviously less than area of flange, which is 176,000. So, masasabi mo ngayon na A is less than T. So, that is figure 2. Ito yung maximum AC. Note na mas maliit siya sa A1 or area of flange. So, that means A is less than T. Next. So, again, we compute the value of A, which is simply maximum AC divided by capital B. You store this to letter D. And then C, small c is equal to A all over beta, 124.24. You store this to letter A. Then we compute the lever arm Y1. Take note na wala na tayong A2 kasi hindi naman siya lumampas ng flange. You store this to letter E. Now, F prime S is 600 times C minus D prime all over C. This is to check if your compression still yields. So, it is greater than Fy, which is 280. Okay? So, you store 310.24 sa letter F. We are now ready to compute your AS1. So, that is your 0.85 F prime C times maximum AC divided by Fy. You store this to X. So, nominal 1 is 0.85 F prime C max AC Y1 divided by 1 million. You store this to Y. Likewise, capacity MU is PMN is equal to 1295.32. Okay, we now proceed to the actual design proper. So, i-compare natin yung capacity MU, which is PMN1, 1295.33 sa given na MU. Note na itong 1295.33, ina-analyze natin yung T-beam as singly reinforced beam. So, ang ibig sabihin yan, chine-check natin kung kailangan ba talaga ng doubly reinforced beam or kung kailangan ng compression bars. So, lumalabas na hindi kaya nung 1295 or yung singly reinforced T-beam yung moment na 1450. Okay? So, it is mas malaki yung moment na 1450. So, kailangan natin ng DRB. So, which leads us now to our excess moment or MN2. So, MN2 is equal to MU divided by V minus MN1. Next, check natin ngayon yung figure. Okay, eto na siya. Remember na yung MN1 ay maximum AC lang, which is your C1 and C2. Take note na walang compression bars dito. So, ito yun, yung MN1. Tapos, yung MN2, ang bubuhat sa MN2 yung compression bars C prime S. So, ito yung bubuhat sa excess moment. Okay, so AS2 is MN2 times 1 million divided by Fy D minus D prime. You store this to letter M. Next, we now compute your required AS is equal to AS2 plus AS1. So, 1305.86 plus ito, 10,771.67, or that is, recall M plus recall X. Yan yun. So, yan yung answer. And then, required A prime S is AS2FY divided by F prime S, or that is recall M divided by recall F. And that is 1178 millimeters square. So, tapos na ang ating design proper kasi nakapaglabas na tayo ng required AS tsaka required A prime S. Now, pupunta na tayo ng investigation. For that, kailangan natin ng mga bakal. So, for A prime S or tension bars, let us try 12 pieces na 36. Yung 36 mm na yan, yan yung DB1. So, ang lumalabas na AS ay 12,214.5. Compare this with 12,077. So, mas malaki ang ating actual AS. So, that is okay. For compression bars, let us try 6 pieces 16, which is 1206 mm square. You compare this with 1178. So, it is greater than. So, okay again. Now, we are ready for investigation proper. But, before that, i-compare muna natin yung sample 1 sa sample 2. Okay, sa sample 2 din, we have the same format. Also, similar given. Ang pinagkaiba lang dito ay yung kanyang FY. FY is 345 compared to 280. And yung MU is 1300 compared to 1450. Tapos yung kanyang procedure, parehas lang. Kailangan mo yung D prime, D, beta, C balance, A, check mo yung kanyang distance ng location ng A. We have balance AC, A1, A2, Y1, and Y2. Then you compute the nominal moment and capacity MU. Then you again proceed to maximum condition. Same procedure sa maximum AC tsaka area of flange, but you have to check the location of A. So happen na parehas sila. And then same procedure again, you compute your new A. And then ito yung value ng C, 121.33. Tapos yung value ng Y1 para sa sample 2 is 478.43. Ay, 0.44. Again, you store these values to its corresponding storage sa calculator. This time, you check your F prime S. Lumalabas na ang F prime S ni sample 2 is 303.28, which is less than your FY na 345. So, wala siyang yielding. So, meron tayong comment dito na no yield. Again, you compute your AS1, MN1, and capacity MU. Take note na meron tayong no yielding dito. So, ibig sabihin, medyo magbabago na siya. Now, let's go to the design proper ng sample 2. So, ang excess moment, 35.28. AS2, ayan siya. Required AS, 8754.85. Required A prime S, 247.51. Now, let's go to investigation. Ang pinagkaiba ng investigation sa design, dito, wala ka ng, ay dito, hindi na natin kailangan yung MU. At kailangan meron na tayong nakalagay na number of pieces ng bakal para sa compression and tension bars. Okay? So, almost similar procedures, yung D prime, D, beta, and then we proceed to step 1. find the location of A and then check for yielding. Okay, so for location of A, so A prime S is equal to AS2. Ngayon, ito yung compression bars. So, ilang pieces yung ating compression bars? 6 times pi 16 square all over 4. Yan yung A prime S. So, ito siya, 1206. You store this to A. And then, AS, that is 12 pieces na 36. You store that to letter B. Ngayon, meron tayong AS1. AS minus AS2. So, AS1 is equal to AS minus AS2. And area of flange is capital B times thickness. And then area of concrete is equal to AS1 Fy divided by 0.85 F prime C. You store this to letter C. Note na area of concrete is less than AF. So you can say that A is less than T. Let us compare this to figure 1. Okay? So, eto siya. Let us compare this to figure 2. Ito yung kanyang AC. So, small a is less than the thickness of flange. So, A is less than T. Yan. Okay, before proceeding to step 2, let us compare sample 2 with sample 1. So, same procedure. Ang pinagkaiba ni sample 2 kay sample 1 ay yung kanyang Fy. Sample 2 is 345, sample 1 is 280. And then, ang kanyang bakal ay 2 pieces 16 and 9 pieces na 36. Notice na wala ng MU dito kasi investigation eh. Next is, meron tayong A prime S and AS, AS1, and then area of flange. Again, it is A is less than T. Okay? But, this time, nung chinek na nung compression yielding, sa sample 2, no yield. Okay? Pero sa sample 1, nag-yield. Okay. So, dito tayo ngayon sa sample 2. Let us skip sample 1 muna dahil may mga similar equations or similar procedures na pareho. Pero dito kay sample 2, mas mahaba nga lang. Back to sample 1. So, F prime S is 600 times C minus D prime all over C. So, that is greater than Fy. So, meaning your compression still yields. Next is Fs is equal to 600 times D minus C all over C. Note na ito yung tension yielding. Dapat mag-yield sila pareho. Yan ang condition ng case 1. Next is we now compute your nominal moment. So, dalawa ang area natin dito. Ayan. So, 0.85 F prime C, AB times D minus A all over 2 plus A prime S, Fy times D minus D prime. Bakit dalawa ang area ang sinasabi ko? Meron yung concrete, AC, tsaka yung A prime S. Ito yon. Okay? So, your capacity MU is PMN 1463.44. We compare this with MU nung design kanina, which is 1400. So, therefore, safe.